Edexcel C1 2015 question 10. A curve with that equation passes through a point. Given this, find f of x. So we're going to integrate from, this is dy by dx, remember. F dash of x is the same as differentiate y with respect to x. So undo the differentiation, get back to f of x, which is why we're pointing, because we're going to find c. And then p lies in the curve. The normal to the curve of p is parallel to this line, find the x coordinate of p. Okay, so that's using this equation. So we're going to generate the original equation, this one. Find c, write it out, get 5 marks, and then we're going to find the normal to the curve parallel to this one and find the coordinate p. Okay, so f of x is equal to the integral of 3x to the half over 2, take away 9 over 4 times x to the minus a half plus 2 with respect to x. So add 1 to the power is x to the 3 over 2. Divide by 3 over 2 is the same as times by 2/3, so that undoes the 3 halves. Add 1 to the power is x to the half. Divide by a half is the same as times by 2, so this is minus 9 over 2. And then the 2 becomes 2x, and then add c, so that's what y is equal to, or f of x. And we know that f of 4 equals 9, and that gives us that 9 is equal to 4 to the 3 over 2. Take away 9 halves of 4 to the half, plus 2 4s, plus c. So c is going to be 9, take away 4 rooted and then cubed is 8. 4 rooted is 2 times 9 over 2 is 9. And then, so that becomes plus, and then we're going to take away 8. So 9 take away 8 plus 9 take away 8, c is equal to 2. Therefore, f of x is equal to this one, and we can replace the c by 2, look. So x to the power of 3 over 2, take away 9 over 2, x rooted if you want, plus 2 x's, and then add 2. There's my final answer for part A. Part B, find the x coordinate of p when the normal to the curve is parallel to this. Rearranging that, we've got y is equal to minus x over 2, and the gradient of that one is equal to minus half, of course. So the normal is parallel to that, so gradient of normal is equal to minus a half, gradient of tangent is equal to minus 1 over minus a half is equal to 2, and at dy by dx is 2, because dy by dx is the gradient of the curve at any point, which is the same as the gradient of the tangent of the curve at that point. So the gradient of the tangent of the curve is 2, so the gradient of the curve at that point is also 2, and that will be equal to 3 root x over 2, take away 9 over 4 root x's, add 2, so the 2's cancel. So this is equal to 0 now. So for this, take away that to equal to 0. That gives us 3 root x over 2 is equal to 9 over 4 root x. So let's cancel those two. Let's cancel these two and move the root x up. And we've got x is equal to 3 over 2. This 3, that 2 at p.